So in the previous lecture we saw the structure of real numbers. In fact, we kind of constructed it by first defining the natural numbers. Just go we denoted by n with a line. Then we talked about integers, which had all the natural numbers and their additive inverses and the identity element 0. We denoted integers by z, and then we had the set of all rationals which were of the type p by q, where q is not 0 and p and q both are integers. So one by one we defined all these sets which were part of the real number, but at the same time the problem arose that is there a real number whose square is 2, for which x this thing is satisfied. In fact, this problem was identified by Pythagoras when he saw that if you construct a square of 1 unit square, that means all the sides are of 1 unit length, then if you measure the diagonal, this is not represented by any rational number, right? So what x satisfies this, and this is what we are going to prove in the next result, that there is no rational number whose square is 2. We use the method of contradiction to prove this. Contradiction means we will assume the opposite of what we have to prove and then proceed, and while proving we come to a point where we get a statement which is incorrect. That means the statement we had assumed was wrong. So we say, suppose there is a rational number say p by q with q not 0, and also assuming that the GCD of PQ is 1, that is the rational number is in the simplest form, such that p by q square is equal to 2, right? So as and when we proceed, we will come to a point where we'll get something which is not wrong, which is not right. So we will say that means the whatever we have assumed here is not correct. Now this means p square is equal to 2q square, right? And the moment we write 2 times q square is an integer because q was an integer. So p square becomes an even number. Now what is an even number? Any number of the type 2n where n is an integer is an even number. What is an odd number? Any number of the type 2n plus 1 or 2n minus 1 where n is again an integer is an odd number. So 2q square is an even number. That means p square is even, right? Now if p square is even, this means p also has to be even. Can you prove this? So let us try. Now suppose p is not even. If it is not even, the only option it has is that p is odd. That means p is of the type say 2n plus 1 for some integer n. So what will happen to p square? P square is equal to 2n plus 1 square, which is 4n square plus 4n plus 1, which is 2 times 2n square plus 2n plus 1, which we can say is 2 times n plus 1, where what is n? N we have written for 2n square plus 2n, which is an integer. So now the moment we get 2n plus 1, that means pn square is also, because 2n plus 1 is odd, p square is odd. But here we are getting p square is odd, but here we had said p square is even. So this is a contradiction, or this is not true, right? So that means p is not even is a wrong statement. So p has to be even. So if p is even, so we say let p be equal to 2n or 2k, whatever you want, for some k belonging to integers. So what happens to p square? P square will be 4k square. So if you put this in 1, what do you get from 1? You get 4k square is equal to 2q square, which implies q square is equal to 2k square, and this again gives us that q square is even. And like we proved that if p square is even, then p is even. Here also, if q square is even, then q must be even, right? And so if p and q are even, this gives us 2 is a common divisor of p and q. But see what we had assumed. We had assumed that the greatest common divisor of p and q is 1. So that means we get a wrong statement or a contradiction. So which can we write? Which contradicts that GCD of p and q is 1. So hence our assumption that there is a rational number whose square is 2 is incorrect. So that means there is no rational number whose square is 2. So such numbers which are not rationals give us the numbers which we called irrationals or irrational numbers. So real numbers consist of all the rationals and the union irrationals. And mind you, this union is a disjoint union, because no rational number is an irrational number and no irrational number is a rational number. So with this, we have touched a very important result, and we'll move on to the next topic in our next video.